So being October 1st, I'm again excited to be able to start by kicking this off with our event here is going to be on data translation. So as much as we'd love everyone to be using SOLIDWORKS, the reality is that other CAD systems do exist, and you may find yourself in situations where you need to get those files into SOLIDWORKS. Maybe it's files from a supplier, maybe even legacy data from long ago when you maybe were using a different design software. So we're going to look at options for best utilizing that data. So CAD file formats are kind of like languages, right? They oftentimes require translation in order to be meaningful to the audience. And third-party CAD to SOLIDWORKS, right? Just like translation, in this case, maybe Google Translate, that's not going to help us in the SOLIDWORKS realm, but we do have some tools that might function similarly. So translating from one language to another, that depends on how well the interpreter is doing and on what languages are actually being used. So sometimes things do not directly translate, and an elaboration or workaround is needed. And CAD translation is really no different. And I'll show you some of the tools that we have to work with SOLIDWORKS today. We'll take a look at these 4 topics: the import formats and file types that we have to work with. We'll look at diagnosing and finding any problems, as well as some tools to repair any of the faulty geometry that we might recover or might encounter. And then 3D Interconnect, that's a powerful newer tool in SOLIDWORKS that allows us to work with non-SOLIDWORKS files in kind of a different manner. So there are a few formats that SOLIDWORKS can import, including 2-dimensional, but these are going to be the most common. And these are listed in orders of preference. We get that question a lot of times. Well, what file type should we get? And we'll get into the answer for that in more detail. But parasolids are one of the most preferred because it is actually the modeling kernel used by SOLIDWORKS, and it is actively maintained, which is a big characteristic. That means as CAD technology changes, those file types are actually adjusted to keep current. So step file, that's another common one. There's different versions of step files, and this again is related to the fact that it's actively maintained. So you might see step 203, step 242. So the higher the number, really the more recent it is. But step 242, for example, it includes more than just model data. It actually includes almost like a layer where you can have your annotations, your 3D annotations, your manufacturing information can actually be translated with that file type. ASYS, SAT, that is also maintained by Dassault Systems, so that is another pretty successful file type. IGES, that is a common one. It is actually not maintained, so that last update was in 1996. So really that would be lower on the file type that you would try to request. Obviously you don't always have control about which file types you might be receiving. Now we can also open some native CAD formats, okay, so not just these neutral types. CATIA, still have to deal with some translator licensing. Inventor, big advantage, you can actually get the feature history, as well with ProE and Creo. You can generally get some of the feature history that you could potentially use for editing. Solid Edge, we can also bring those ones in directly, and UG. And you can just find all those on the file type options when you're actually bringing it. So the benefits here, the neutral formats, we can actually edit those without having to have that CAD system. So maybe we bring in a file, maybe it is the step file, and we need to do something like add draft to help make it moldable, right? So small edits, or I guess they could be substantial. Maybe you need to add some new holes. But you can edit those files once you bring them in. The advantage of using native files is it's fewer steps, right? It's not CAD system A kicking out a parasolid and then SOLIDWORKS importing that where you have those multiple steps, right? Native files, if we can bring those in, that generally is going to be desirable because there's less steps involved, so it's sort of taking out that extra step. And then, of course, the feature tree as we discussed. And using preferred file formats that we listed, right? Native is generally better than parasolid and step, sort of following that order we mentioned. In previous releases, you didn't actually find the import-export options in your regular system options, you'd have to get there by browsing to the file and then hitting the options button on the actual opening interface. So the same settings are available here, just now you can find them in your system options. And notice the file format, you can click that and do the drop down and pick the type, and you'll see a few specific options, or the main global options are going to affect everything here just on the general. And there's an example of if you were to choose IGES, you can see a little bit different options exist. So let's go ahead and take a look at some of those examples. So what I'm actually going to do is this tire rim here, I'm going to open this file up 4 different times with different settings enabled here. So the first one is I'm going to use this solids option with no entity check. Okay, so we'll go straight to those system options. Right at the bottom, import and export. And just like I mentioned, the drop down there. All right, looking back at our general, so this time we're doing the entity check there, that one turned off, and then try forming solid on. We'll come back and look at these other ones soon. There's our step file. So it's doing the import, creates it. The file looks great at first glance. Obviously, we want to be a little bit more observant and I guess critical of it. So if I do like a section view, that becomes pretty obvious that's looking hollow inside there. Or if I look at the left, I can see that it has surface import. So that, of course, indicates it is a surface model. Running this import diagnostics tool, I can see these problems highlighted. Right? So we end up with about 5 different gaps that were discovered. So really, it's not really a clean import. So we might as well try some other options, and hopefully we can get better results without a ton of effort. So next option, we're going to use the solid. Right? We want to import solids, but this time we're going to turn on entity check. We'll get more on what that does. Same step file there. So looks pretty much the same. Doing my section view, this time I like what I see. Right, it is a solid model. At the left, I can see solid bodies listed. That's encouraging. Still running the import diagnostic. It did find one face error. So generally, this is a much surface here. This is a much better model because it's solid, but it still did show that error when I actually ran the import diagnostics. So it didn't show that immediately, right? You have to run the diagnostics. So it is a tool that's worth running before you use this. Okay, so now the next option we're going to use is BREP mapping without entity check. So BREP is boundary representation. What it does is it changes the way that SOLIDWORKS is going to process the model information during the import. So it's going to try to use boundary representation to directly map the topologies as it imports this data. So generally this is going to be faster than the previous option we had that was knitting the surfaces, especially for your more complex models. Let's take a look at the results we get with this same file here. Turning that one off, you see BREP mapping. There's our step file. Now I do see surface imported. We've already seen that that's a little bit of an indication that it's not, well, it is an indication that it's not a solid model. Running the import diagnostics, we've got some more problems there. I can use that as a way to zoom in and kind of more easily find the problem. And final option here with this example is still the BREP mapping, but that entity check that we're going to use, we're going to do yes on that entity check. So let's go back to our options. And this time I'll access the options in the the other way, right there in our open interface. Brings me the same set of options. So you can see it says constructing topology there. So again, indicating that it's processing a little differently. Looking like a solid model. And then you can see at the left, that's really what we're hoping to get. The no faulty faces exist. And of course, I said it was a solid. Section view certainly confirms that. So what are the right settings? I guess that really would be the million-dollar question. The answer, I guess, is that there are no completely right settings for anybody. So they need to be changed from import to import. So knowing what options are available is really going to be your best approach. Maybe if your files are similar enough and the CAD system that the initial files are coming from is the same, usually you'll be able to pick one and it'll be a little bit more consistent of trying that one first next time. But we just imported the exact same file 4 times. One time it was almost unworkable. I think 2 times that was the case. One time it had some gaps which could probably be easily fixed. And that last option, it imported perfectly. So we may need to try a couple of these different options before we get the results we're looking for. So then why do we need to do this? And why do we sometimes have these problems? I guess we could also say, do we really need to do something about it? We don't always need to fix this type of issue. Right? Maybe if I just need that model as reference to see how things fit up in my assemblies, maybe that sort of problems surface model is good enough. Right? I can still put it in my assembly, can still see how my parts might fit up next to it. So it is very possible that, yeah, it's a problem, the model's not perfect, but I don't really care. So evaluating how serious the problem is and if a 3D geometry is ultimately required. And if it's needed for downstream, like I'm going to maybe do the toolpath programming or use it to design mold tools, right, then it is going to be important that I fix that. Okay, but what causes this? Could be different tolerances in the 2 CAD systems, or maybe the receiving CAD system doesn't support the same entity, right? It might not be represented correctly. And you might end up with some missing entities, right? If the gaps are large enough, some of the healing tools might not be able to close those gaps. As far as some of the tools we have, the check entity tool, right? It's right on your command manager, specifically on the evaluate tab. It is a powerful command, and it quickly can scan and identify all sorts of things on your geometry. It can tell you the minimum radius of curvature. Maybe you have a shell that's failing. That can be useful information. Or some of the things it can do is check for any invalid faces or edges, and that only takes a couple seconds usually. So let's take a look at that import diagnostics tool that I was actually using earlier. I used it just to identify problem areas, and it was very, very good at that. But it does also give you some tools to work on repairing those. So I can right-click these individual gaps or the faulty faces, and I can see it'll tell me what the problem is. A lot of times it's not the clearest. It might say general geometry problem. But down here, there are the attempt to heal all, or attempt to heal all gaps. And eventually, if problems are all repaired, you get the nice green indication that we saw once of our previous model, letting you know that, hey, it's good to go and it's valid. Well, it doesn't always fix everything, unfortunately. So then what do we need to do when that happens? Well, you can actually run that diagnostic tool again. Because if it repairs some, now it's made new faces and edges perhaps. So running it a second time occasionally does give you, better results after that second time. Round trip the model, this is kind of a creative approach. But you could take your model and save it as a parasolid and then bring that parasolid back in. Now, it seems a little odd, but being that parasolid is the best type, when you get that file and bring it back in, it might better represent and be able to close some of those gaps. Or you go back and say, well, that didn't produce the best geometry. Hey, can I get a step file and let's test that out. If that doesn't do it, you might have to dig deeper and get into the surface modeling and maybe recreate some of that geometry. And more on that, you might have to create copies of surfaces, do surface offset. Maybe you delete and patch or fill, get rid of and patch that problem area using other tools like trimming surface, knitting those. you don't have the geometry to help create the new surfaces, you might actually need to get splines involved, right? Maybe on the surface or maybe even 3D ones. Still trying to close that open area, right? We might have to use filled loft or boundary surfaces. And once we get a good face in there, we might have to use a replace face command to get that one added to the model. And final step, we'd want to use that same check entity command to make sure we have valid geometry. So the benefits of our repaired model, this goes back to what I was saying as far as do we really need to do this? It's ready for downstream edits. You can even use FeatureWorks to help recognize geometry. Or, like I said, create mold tooling, right, or analysis, or the tool paths. You want your valid geometry for those steps. It'll also be a smaller file size, and then no issues using it downstream. Right? The geometry is going to be more likely to be dimensionable, create mates to it. And so now the same example you see on the slide here, let's actually look specifically at that one. And what we'll do is we'll import it, try to fix what we can, and then address any remaining issues. This one is a step file. Go to my options, and you can see we're doing the entity check, as well as the tri-forming solids. It's something like a snowboard binding. It is coming in as a solid, so that's always encouraging. Now, I could have an option that would automatically run import diagnostics. It's a little checkbox that you can turn on. So really, I'm doing this every time, so it might be wise to do that. You can see the what's wrong was telling me a general geometry problem for that one. That one as well. Self-intersecting face. So again, these aren't the clearest errors, but then you kind of cross your fingers, it seems like almost, and hit attempt to heal all. One of those disappeared, another one has a check mark. Just like I said earlier, hey, let's hit it again. In this instance, it didn't give us a perfect result. All it did is get rid of the one that was already repaired in the list. So now I'm in a scenario where I still have a single face that has the problem. And it happens to be where all those fillets converge. So to get more information, I'm using this check tool. And what I'm actually going to do is check for the minimum radius of these faces. Really what I'm trying to figure out is what is the radius of these fillets. Right, what's the radius of those fillets that all converge? So really, they're like the adjacent fillets. And this is in an assumption that I'm going to have to recreate some of this geometry. All right, so we've got 2 at 2.8, and then we've got 1 at 3 here. Spinning it around, now it looks a little bit clearer. That's the face, that's the problem. So go into our surface commands, which can be intimidating at first. I'm going to delete the problem face, but this delete command does have some nice tools that can help patch it. So if I try to use this patch option, what that actually does is try to extend those adjacent faces. So that can't be solved here. This delete and fill, it's almost like it's doing a filled surface command on that new gap. And you can see that doesn't look too good, right? Topology, it does close the gap, but the geometry there, like that face, looks pretty awful. So that one's not great. We could try turning off tangent fill. These are like the easy methods, easy things to try. It's just a step or two, but looking at the zebra stripes might give you a little bit more indication that it's not really a smooth transition. So good try, but didn't quite do what we want. So let's just get that thing out of there completely. And now you can see it is surface model. So it almost seems like we've taken a step backwards, but at least we don't have a problem face there anymore. Right, so it's surface, so now we need to go ahead and do something about that, right? We need to patch that hole one way or another. So what I'm going to do is you don't just try to patch the area that's the problem. Sometimes you want to take an area that almost includes the problem area and a margin around it. So I did a copy of those existing faces, and I hid the original so that I can focus on just the geometry that's contributing to this problem. So these 3 faces that were copied, I'm now extending them so they go past sort of their intersection, which is generally with surfaces what you want to do is overbuild things. Okay, so now I'm going to go do the trim Doing a mutual trim, so really I'm going to get rid of the sections that go past each other. Just selecting and keeping these guys. And remember, I took the measurements, the dimensions of those fillets. So that information is going to help me recreate these. They're going to be edge fillets. Starting at my larger one, let's do a 3mm fillet. And the other one, that was a 2.8. And so that looks good for the recreating that problem area with all the stuff around it. So I'll hide that, bring back the original model, and now I need to get rid of the stuff that I just recreated. So this is just going to be the regular old delete face, not trying to patch it or anything, because I've manually created this patch. Let's show it. Now it's still two surfaces at this point, so my knit surface command is going to let me merge those, and then it also lets me create a solid, assuming it's airtight. So perfect, that did get me to my desired results, right, as a solid body. One way to really, one last step really to verify it's all good is that check tool, right, checking for any invalid geometry, and none were found. So now I can confidently use this for downstream modeling or design process, right? So what about a little bit more complicated geometry? Where the gap is maybe worse, and it's not as simple as copy and then recreate some fillets or something. So you might actually have to get into 3D sketching and try to manually create some of this. So let's take a quick look at that scenario. The file I'm opening, it is a SOLIDWORKS file because the import was already done. It was brought in as an import. It looked this dirty, and then it was saved just to make it easy for me to open. But yeah, I could try other file types maybe before I get deep into this. But you can see there is, two, I guess, regions missing with not clean boundaries. So if I select all the edges of this first open area using my filled surface, I can tell it to do a curvature continuous patch. Right, so it's going to try to maintain that higher level of continuity between those existing adjacent faces. I was able to tell it to merge, so that just was essentially knit automatically to the existing. So that worked out well. But now these gaps I have right there, I don't have nice edges. So going in here, I'm going to do a 3D sketch with a spline, which is another thing that can be kind of intimidating. But just a 2-point spline, so I'm manually creating boundaries. I'll make that tangent to that existing edge. All right, tangent to this one as well. And then I'm going to use the same fill tool that I was using. Just I'm substituting that piece right there for an edge that I kind of wish was there. So to grab all these other edges. There we go. So all these edges, I still have control of the continuity. Like I can set them to curvature continuous to some of these faces I already have. I can only get away with contact for my sketch, but that I want curvature. That one I want curvature. Now these bottom ones, I want contact, right? I don't want to try to be tangent or curvature continuous to that flat face on the bottom. That would make it bubble out towards me. And there's that last one. There we go, curvature. So really this big gap that I had, this worse one, I'm really trying to attack it, break it down into smaller regions that are a little easier, more manageable. So using that same technique, a 2-point spline, it's a new 3D sketch, helping keep it smooth to the existing edge boundaries here. Our same filled surface, right? Contact. Okay, I can't. I'll select some other edges first, and then I can change to the curvature. All right, so I can select all these at once. The non-sketch edges. And and set those. There we go, curvature continuous. And I forgot to hit merge results on that interface, so I'll go ahead and do the knit command. So now this is one loop, and you see that light blue boundaries. This is nice because I can just right-click it and do select open loop. Just an easier way to select all those edges. So one final filled surface. And then at the bottom, you can see there is merge results and even create solid. So now I have a solid. So I did successfully get that patched and turned into a solid. So that's great. But another thing that's great is if I actually recognize symmetry, that would have saved me some time, right? I could have said, hey, this is symmetric. Let's chop it in half, mirror the half, and then turn it into a solid. So anytime you can recognize symmetry or patterning can be a big time saver. So now switching to something that's a little bit more, I guess, technical, a little bit more advanced, is 3D Interconnect. So it's a cutting-edge 3D multi-CAD data referencing technology. And what does that mean? Well, instead of just doing an import of files, it actually can maintain a reference to that non-SolidWorks file type. So it can work with multiple systems, and again, not an import. However, it can do that, but it maintains a link so that if that Inventor file were to get changed or updated, or a Creo file, you get a new version of it from a supplier, that assembly can actually update and reflect that. So in this example, we've got the Lego front-end loader there, and from Inventor, almost 759 parts, and importing it like what we've done, it took almost 13 minutes. You do have to install Inventor View, which is their version of a viewer for SolidWorks to be able to bring that in. And then you can see all these gaps that we would spend definitely hours to repair that. And there's no link back to the native. So if there was file changes, I wouldn't see that reflected. So now 3D Interconnect, still the same number of parts, much faster to open. No additional software required, right? It's just an option when you're bringing things into SolidWorks. I don't need to run import diagnostics because it is powerful and does some healing automatically. And it keeps that link as one of its great characteristics. Anything changes in that file, the Inventor file in this case, maybe they changed the bolt pattern of one of the rims, that would be updated here. So in our comparison, the 3D Interconnect version is definitely better. So quick example of going through this. This one's high speed. So in this assembly, these are all SolidWorks files. And I'm going to do Insert Component. And I can browse, and the file type I'm going to choose is Inventor Part. So there it is. So it's an IPT for the battery. So I'm inserting it into an assembly. I didn't have to do a file open or anything. Placing it there. You can see it has a different symbol in the tree. It has kind of a green arrow on it. And then we're going into turbo mode for me to put all these mates and put it together. We can focus on the actual 3D Interconnect features. This is what it takes to win the Model Mania Challenge at SolidWorks World, that kind of speed. But what I'm doing now is I'm editing this part, and I'm changing its extrude definition. I'm going to say send that extrusion all the way up to a surface of this new non-SolidWorks part. So really, you wouldn't do this without this functionality, because why would I need an extrude to go up to a dumb solid? Right? This only helps if changes might occur. So now what I'm going to do to simulate a change is I'm just going to copy and paste a different version of the battery on top of itself. So this simulates some other user, opening, modifying, and resaving that. Basically, it has a new save date. So I replace it. I go back to my model. I can rebuild it. But now the symbols in the tree, right, it still shows that it's linked to the external file. I can right-click it, and there's Update Model. So that is basically reloading. And look at that. So it's a new version of the battery, larger diameter, longer length, and the housing updated because of that reference, because of that up to surface. So it's not necessarily just a dumb solid anymore. It's maintaining that reference. So fixing a few other geometry issues here. Okay, so that is inserting it into an assembly. Just a couple more things that we're looking at here with this tool is bringing a part. Okay, so now I'm actually doing a file open of this Pro-E part, Creo, and you can see it's not an assembly, but it still shows that link at the left. I'm just going to add, just to make it recognizable, let's just add a quick, we're just adding a feature here, just a little extrusion. And so this better simulates maybe how it parallels importing a part, right? Importing a step file or something. So it comes in clean. I can still use it for additional edits. It shows the part reference, shows my new feature there. And now let's go ahead and put this in the assembly. Yeah, we'll save that. And a little bit of turbo mode again. So now in this case, we're going to simulate with Creo when it saves a new file, right? A new version has the .1, .2, .3 on the end of it. So rather than overwriting a file, I'm just putting a .2 version of it in the same directory. Again, simulating the newer version. It was in the part file that had the reference. So right here, it shows that the newer version exists. So I can do update model. So again, a scenario of it preserving that reference to that non-SolidWorks part file. It updates here. And we can see those changes. So that was in the part example. And then finally, to compare it to our dumb solid import is you can actually right-click it and do break link. And so now it doesn't maintain that reference, which does have some advantages. Right now I can send this to anybody and it's not looking for that original Creo file. So I can break the link just by right-clicking it. And this allows me to maybe, I guess, get some of those advantages of the 3D Interconnect, perhaps, of being a slightly more powerful conversion tool, where it seems to be able to handle some of the gaps a little bit better without having to maintain that reference. So that option, it would just be in your import options. It'll be like the top checkbox there will be Enable 3D Interconnect. So really, I think the reasons that you might do that is really you don't want to maintain the reference to another external file. And maybe you want to use that in your assemblies and everything and have it function just as if it was an imported part. That would be maybe reasons why you would break that. So that really concludes what we were talking about today. So living in a multi-CAD world, really what we're talking about, though, is working with all these imported file types. So we looked at the different formats. We generally left it at use the preferred formats, so work with the ones that are higher preference. In that case, maybe native files, and then Parasolid would be your main two to try. Diagnostics, what do you do? How do you try to find these problems? We looked at import diagnostics. We also looked at that check tool. Repairing tools. Import diagnostics does have repair options, or unfortunately maybe you have to get pretty deep into surfacing to patch those, all assuming you need that high quality 3D geometry, which sometimes you don't need, right? You got to be honest and say, well, it might take me a couple hours to fix this, but it turns out the value that I get from a fixed file might not make it imperative. And then we looked at the 3D Interconnect as that powerful tool that's recently added to SolidWorks, and just some of the big advantages that it can do. But faster, open. So really I would put it in the list of things to try if you're running into some import problems. So we'll conclude there. And again, this was our first web presentation here of our Design Innovation Month. So we have some of these every day, as well as our big 2020 rollout events that we hope you can come join us at. But yeah, please sign up and join us on some more of these WebExes, and check out our blog too, because like I said, we have at least 2 blogs being rolled out every day, even on the weekends. So thanks a lot for joining us.